Welcome to AuditOne's comprehensive report on Coinlend smart contract security. Coinlend DeFi is a cutting-edge, decentralized, peer-to-peer lending platform built on the Ethereum blockchain, designed specifically for lending and borrowing ERC-20 tokens. Coinlend DeFi is at the forefront of the decentralized finance DeFi revolution, providing a reliable, efficient, and inherently trustless environment. Unlike traditional finance, which is largely based on trust and intermediaries, Coinlend DeFi operates on the principles of blockchain technology, ensuring secure and transparent transactions without the need for a trusted third party. DefSec Übermensch and Minquanem have audited the Coinlend smart contract in May and June 2023. The audit concluded with impressive scores: 98% in security, 98% in code quality, and 95% in documentation quality. Our expert team identified 7 high-severity issues, 7 low-severity issues, and 12 medium-severity issues. Let's take a closer look at these findings. Loans can be liquidated without checking loan duration. We recommend including a check to ensure that the loan has exceeded its duration before proceeding with the liquidation. Assumption of constant token decimal places can lead to incorrect value calculation. We recommend dynamically determining the number of decimal places for each token rather than assuming a constant value. Most ERC-20 tokens include a decimals function which returns the number of decimal places for the token. We suggest modifying the getLatestPrice function to call this function and adjust the price calculation accordingly. Lack of token whitelisting leads to deposit of fake tokens. A token whitelist should be implemented, where only approved tokens can be deposited into the contract. An only owner function should be added to the contract which allows the owner to add and remove tokens from the whitelist. Reentrancy vulnerability in ERC-777 token. Consider implementing reentrancy guard. Token can be minted with fake token. The buy credits function should include a check to verify the legitimacy and value of the ERC-20 token used for minting Coinlend credits. This could be done by maintaining a list of acceptable ERC-20 tokens that the buy credits function accepts. This list can be managed by the owner of the contract to ensure the authenticity and value of the tokens accepted. Significant rounding error in loan-to-value calculation. To mitigate this issue, remove division by 1E18 as it is not necessary due to the fact that we divide token lending total value by token collateral total value afterwards, which cancel the decimal effect. This will help to increase the LTV precision to get an accurate value of the borrower's position. USDC used to buy coins are locked in the contract forever. Consider adding a function to allow users to redeem coins for USDC in the Coinlend credits contract. Lack of upper bound check on interest rate may lead to excessive interest rates. An upper bound should be set for the interest rate to ensure that it does not exceed a reasonable value. The appropriate limit can be determined based on platform policies or market conditions. Also, correct the error in the require statement where LTV is being checked instead of interest rate. Incompatibility with rebasing/deflationary/inflationary tokens. Ensure that to check previous balance after balance equals to amount for any rebasing/inflation/deflation. Add support in contracts for such tokens before accepting user-supplied tokens. Consider supporting deflationary, rebasing, etc. tokens by extra checking the balances before, after, or strictly inform your users not to use such tokens if they don't want to lose them. Incorrect fee verification in loan payback. The fee should not be considered in the verification, not added to it. This will ensure that the borrower is only required to have enough funds to cover the loan amount and the interest. Should check return data from Chainlink aggregator. Consider to add checks on the return data with proper revert messages if the price is stale or the round is incomplete. Uninitialized discount variable. To fix this issue, a setter function should be added to allow the contract owner to set the Coinlend credits discount variable. This function should only be callable by the contract owner to prevent unauthorized changes to the discount rate. Additionally, the Coinlend credits discount variable should be initialized in the contract constructor to a sensible default value. This will ensure that users who hold Coinlend credits tokens receive a discount on their fees from the moment the contract is deployed. ERC-20 approve race condition. The issue can be remediated by the use of increase allowance and decrease allowance functions to modify the approvals. Lack of ownership, transfer functionality. Implement a transfer ownership function that allows the current owner to transfer ownership to a new address. This function should emit an event to record the change of ownership. Also, consider implementing additional security measures, such as a delay or multi-signature requirement for ownership transfers. Incorrect interest rate check allows users create unreasonable high interest rate loan. Consider fixing the interest rate check to interest rate =1000 to ensure that users cannot create loans with unreasonably high interest rates. New fee should not be applied to active loans. Consider recording the current fee to the loan struct at the creation time to avoid this issue. Owners should not be able to mint currency to their wallets. Consider minting to address this instead in the mint function. Borrower can abuse late repayment to always repay the loan late. Consider applying a fee when the borrower repays late or a higher interest rate for the late repayment period. Inability to use common ERC-20 tokens without success value return in protocol. To address this issue, it is recommended to incorporate the Safe RC20 library. This library enables the transfer of ERC20 tokens that do not provide a return value upon successful transfers, ensuring compatibility with the protocol. Lack of comparison between min LTV and max LTV could break functionality. Introduce a comparison check in the setter functions to ensure that min LTV is always less than or equal to max LTV. In the set min LTV function, check if the underscore min LTV being set is less than or equal to the current max LTV. In the set max LTV function, check if the underscore max LTV being set is greater than or equal to the current min LTV. If either condition is not met, the function should revert with an appropriate error message. Ownership cannot be transferred. Introduce a function that allows the contract owner to transfer ownership to another address. This function should only be callable by the current owner to ensure security. A common practice is to use the ownable pattern, from OpenZeppelin for example, which includes an only owner modifier and transfer ownership function. The transfer ownership function should emit an event to provide visibility of ownership changes. Centralization risk due to exclusive minting rights for contract owner. Consider introducing decentralized governance for minting new tokens, or establishing clear predefined rules for when and how new tokens can be minted. These rules could be based on specific network events, thresholds, or tokenomics principles. Alternatively, you might want to consider having a multi-signature contract or a DAO to govern the minting process. This would ensure a more democratic process for minting new tokens with decisions made collectively rather than by a single entity. The contract owner will always be an externally owned account, EOA. Consider using ownable two-step contract from OpenZeppelin. Lack of upper bound check in set fee percent function. Implement an upper bound check in the set fee percent function to prevent setting unreasonably high fees. Deposit token accepts 0 amount. It's recommended to add a requirement that the underscore amount must be greater than 0. Loan with ID =0 can be taken without creation. Consider fixing the issue by initializing loan count =1 so that a loan with ID =0 is considered invalid. The Coinlend team has meticulously reviewed all findings and corrected every error identified, solidifying the highest standards of security. Discover the full details in our comprehensive report. Find the link under the video description. For more information, visit our website or follow us on social media. AuditOne, your trusted partner in blockchain security.